Hello folks, welcome back. We're here doing some more patent fishing. This time we might even include some design patents, which have no mechanism to them, so they're really just pretty line sketches. Oh, there you are. I see the comment now. So, what now?
Nothing to it.
All right, so getting started right away. I pulled one up. It's Mr. W.C. Fain. Making some concealable furniture. So this actually might be interesting for the tiny house people. I don't know if you can tell by straight on view here, but that's a cabinet like a Murphy bed with a table and bench. Benches fold up into the doors and the table folds up into the cabinet. So here you go, the top view. Let's see, I have to say okay here so I get my highlighter back. So here's sort of the cross section of the wall.
You are a little, your mic is a little...
Low, high?
It is, whatever that's called.
Delayed?
No. Too loud.
Oh, too loud.
It's overpowering.
Overpowering microphone.
It sounds better when you talk lower and slower. Maybe say lower and slower into the mic.
Talk really quiet and directly into the mic. Is that better, my dear? Can you hear me now? Can you hear me less now?
Yeah, that sounds good.
Is it that delayed?
It's a big delay.
Oh, jeez. Why? That's what StreamYard's for. Should not be delayed. All right, well, I'll try and talk a little more regular voice here. Indoor voice.
I'm just going to put the headphones on so I only hear you through the headphones.
Okay. So, again, here's your section of the wall. Table folds up into the cabinet. Got yourself a little spring-loaded mechanism here for the counterweight of the table. Some details. Here's a nice side view. Here's a side view when all packed together. So I think I've actually seen some carpentry channel build this thing. Wouldn't be all that difficult.
Wow.
Let's see. So these later higher numbers and later inventions tend to be a little more straightforward. He's just Walter C. Fain of Norfolk. He's not a subject of the Prussian Empire or something. And it's improvements in concealable house furnishings. And he speaks of his improvement on his original patent, which was from 24. So it took him 6 years to get the patent altogether. And I think, what was the thing I saw here? Here we go. In many apartment houses now being built, the partitions between the rooms are comparatively thin, being not over 5 inches thick at a maximum. Well, isn't that a 2x4 stud wall? Anyway, so he thinks this would be nice and convenient for hiding your concealable. It's more like just, I don't know, storable. So let's see. All of the rest of this is the description of how it works. I think we can pretty much get an idea how it works. But here's his actual claim. In concealable furnishings, a cabinet having a rear wall and an open front, a hinge door for closing the front of the said cabinet. So you can't build any concealable furniture with a back wall and a front door. He's got that claim, or did for some years. Let's see. To support said seat units on said doors when folded, but leaving said seat units susceptible of vertical movement with respect to said doors when in position for use. And then he got it notarized. So there's the kind of thing we're doing. If you like that kind of stuff and you want to see more, please hang out. Like, subscribe, all the usual algorithm stuff. And let's get into it with some new numbers. All right. 25 random numbers from 1 million to 2 million. When should I stop? Let's just keep rolling. Who's going to say stop? Somebody say stop.
Stop.
All right, there we go. Let's just grab the top one. Doesn't take too long.
Don't be penis thing. Don't be penis thing.
Oh, beer preserver. So a kegerator, or a keg tap. I'm not sure. Oh, well, complicated. Well, let's see. Nice turnbuckle to hold the keg on there. Let's see. This was 1911. So,
Two sheets.
Upside down, maybe. I don't know. Nice bowl valve that you got there. This is what we call beer.
Bladder and a ball.
I guess it's a bladder. Let's see, nice little hook there. All right. So, Chris Berwick of Yankton, South Dakota, beer preserver. Be it known that I, Chris Bergesvik, a citizen of the U.S. residing in Yanktown in the county of Yanktown in the state of Yanktown, South Dakota, have invented useful improvements in beer preservers. Full and clear description of my invention. Beer preservers, beer preserving apparatus. Object provide a device which shall constantly maintain the pressure during the dispensing of beer and thus preserve the constant gaseous pressure necessary to keep the beer from
Was the first one ever?
Stalling. Hard to say that it's the first one ever, since this is an improvement in the existing beer preservers. In the newer patents where they have all the extra data, it has all the list of patents that this patent refers to or might be an improvement on. But that's only in the newer doc. Sometimes if it's I'm an inventor and I'm improving my previous invention, they may mention it here as being improvements in the application or improvements on a previous invention specifically. The newer ones have all that history, but I don't know. It's 1911.
Yeah.
You would have thought there would have been something before 1911 for beer to maintain the pressure in a keg, but no, it might be the very first keg topper. Or keg tap, I guess. So here's the actual claim. Now, all the rest of that's the description of the pieces. Oh yeah, looky here. Rubber bag ahead until the bag is within the bag. I knew there's a bag in that barrel.
Ladder.
In a beer pressure apparatus, the combination of a receptacle having an opening and closing for the opening, that'd be nice. A cylinder adapted to be screwed above the opening. A gas pipe passing through the cylinder, a bearing for the gas bag. You're a gas bag. Everybody's a gas bag sometimes. In a beer pressure apparatus. Oh, that's claim 2. Okay. So the claims are all super repetitive. In a beer pressure apparatus, the combination of the receptacle having an opening and closing and bearing at a bottom plate and beneath the plate a gas bag. Number 3, in a beer pressure apparatus, the combination of receptacles, supply, closure of the opening and air or gas pressure supply passing through the cylinder and a discharge of the beer through the cylinder. Yay, we finally got our beer. So that's pretty much what it's claiming is, and that, I don't think modern kegs have this gas bag in them inside them, do they? I don't think so. But the idea, I guess, is that as you drain the beer from here, you increase the pressure outside the bag, and that maintains the pressure on the beer in the bag. Alrighty.
All right.
Moving on.
That's what it looks like.
So we're going to do the second one. We're going to do a design patent, and this, is pretty much just a D in front of the design, in front of the patent number.
The next one? Oh, that'll be interesting.
Oh, Sometimes they don't work. So let's just delete a number and get down in
You're
here.
just going to do design?
We're going to switch back and forth.
Okay.
So here's a combined reel and handle unit assigned to Bronson Specialties of Michigan, a corporation in Michigan. So this is where you create a patent for some place you work for, and therefore
Well, my dad
it becomes assigned. So here we go. It's a rod and reel. What are you going to know? And there's the entirety of the patent because it's a design patent.
61.
They're not patenting what it does. They're only patenting what it looks like.
Tangled that up too.
Yeah, I would have tangled it. Even though it's got the nice little cover up here. Let's see. Side elevation view, top elevation plan view, figures 1 and 2 provide a plate closing off of such side which carries a bearing and a crank. Side not shown, except that the plate member ends of the handle of the reel are shown in plain and unornamented. So that's modern plastic spinning reel. Oh, that's interesting. I hadn't seen that, where you actually quote where in industry this design has been shown before. Hardware Age was 1960. Oh, Hardware Age was a magazine of 1960. So, all right.
Oh, I never saw that before.
I didn't realize that, but when I was looking in back when I was doing these patent researches and going into the library and looking through all the books, a design patent cost about $150 to file this one page. And it only covers what it looks like. So any slight change in the design changes the patent or gets around your design patent. But it's one small thing you can do to help protect your item. And then the trick was, of course, as long as you're waiting to get your patent, you are patent pending. You don't have to disclose that you're patent pending on a design patent, not a utility patent, because a utility patent costs a whole lot more even to start, and you have to do all that description and so forth, and you have to make sure nobody else has done the exact same thing. And if you can't handle all that or afford all that, you can always start off with a design patent. And in the design patent, you don't disclose how your new unique invention works anyway, so you don't give it away to the market, but you get patent pending on your product without much cost. Don't know if that's totally legit. This is not legal advice, etc., etc. Well, maybe we'll get on civil law to answer that question. All right, moving on. Let's see what that number. Let's see what that number was as a utility patent. Oh, one more back. So if we just leave the D off, then we have a utility patent number. There's also plant patents, where you patent a plant. Freight handling apparatus. Figure 1, figure 2. Let's rotate this here.
BF. Bitch.
Looks like a bunch of little rail car looking bearings or something. Oh, it's hard to tell what the scale is here.
It's like a train or...
Yeah. Oh, yeah. Look at this. These are concrete footings.
Oh, that's a rail house.
So yeah, it's a rail house with like an overhead crane. Overhead crane. Freight handling apparatus. Let's go to the full pages. Motor, bevel gears. Bevel gears running underneath all the train cars. Ooh, a little electric, kind of an electric circuit. Bladder thing.
Go up. Oh, that's the gear. Yeah, it's a gear.
Yeah.
Well, that looks like that.
Now, this apparently is the electronics involved, such as they are. Pretty much just wires. And, this looks like a relay, magnetic relay.
Relays.
Yeah, pretty much. And if you want to get into how all that works, you can actually read all the details of the patent. It talks about motor 1, motor 2, motor 3, and motor 4, how those are lined up. I'm going to guess. So I don't know why I decided to start doing this, guessing how it works before we actually look at the description. But I'm going to guess that back up here, when you were looking at a whole warehouse full of them, and this is the cartway, if you will. So your overhead crane here picks up your cart, puts it on this path, and then tells it to go one way or one or the other direction. And as each car rolls over a section, each motorized section, each motor turns on, sends it along its way. I think this is, this is all for this direction, this is all that direction. And so each motor section would turn on when the car got on it, and then until the car got to the other end, and if there's nothing on there, the motors aren't constantly spinning. I'm going to guess that's what all this is for. So, all right, this invention relates to here we go. Benjamin F. Fitch, Greenwich, Connecticut. Signer to Motor Terminals Company of New York. In 32, 4 claims. Relates to freight handling systems, primary concern with the provision of suitable apparatus to control the rapid classification of freight containers. So you get a train come in, it's got cars of this and that all mixed up in it. Take the cars off, rearrange them. Car sorting. And then in my co-pending application numbered 7,707, freight handling apparatus in January of 34. They love the term plurality. A plurality of vehicle trackway and adjacent conveyors, together with cranes adapted to transport freight containers. I was pretty close. Now let's see here in the drawings. Let's get down to the claims. So I may have mentioned it before. We're mentioning it probably once each time. Everything that is the description of how the thing operates is just that, just the description. It's not an actual legal claim. It's only the individual claims down here in the bottom section that are new and unique to this patent or to the industry. Theoretically, they're unique to the art of freight moving systems. And so let's see, in a freight handling apparatus, combination of parallel vehicle trackways, vehicles on the trackways, demountable bodies on the vehicles, plurality of aligned power-driven conveyors extending parallel with the trackway, etc. So all of that, and we repeat that again. And then let's see, comes out a means operable from one of the cranes for simultaneously stopping all of the conveyors. Big old red stop button. And a means operable by another crane for operation of some of the conveyors with the first means has stopped all of the conveyors. And then claim 3, all of that again. An adjacent idle conveyor. Okay. And then all of that again. Automatic, let's see, adjacent idle conveyor and a second automatic means for nullifying the effects of the first automatic means. Said the second means being operable by the starting of said idle conveyor. So basically some switch interlockings of the motion of the conveyors so you don't crush your buddy between 2 train cars or something. So moving on. Oops. There we go. Drum roll. It's always the drum roll. What the? Ooh, an inclinator for carboys. So.
You are very knowledgeable.
Oh, thank you.
Last week on your patents was very interesting. I'm sure this one I will learn even more. You're very knowledgeable on all your videos, says Dana.
Thank you, Dana. Shout out to Dana, channel supporter. All right, full pages. Let's see how we managed to make this cardboard inclinator from 1914. It's like I imagine, well, a carboy is probably beer or wine. What is it? What's in a carboy normally? A signor by Direct and Mesny. I might have to look that up. To Horace M. McCord and Company of Minneapolis, the corporation. Be it known that I, Horace M. McCord, who done sold his invention to his own corporation, apparently, of Minneapolis, has invented certain new and useful improvements in inclinators. Apparently there were other inclinators on the market, and he's making some improvements. Locking the carboy into a carboy holder, such as described in the co-pending application.
Carboys?
A carboy,
Ford
yeah.
Carboy.
All right. Do a little quick look. A carboy is a large glass or plastic bottle usually encased in a protective beaker. So think 5-gallon glass water bottle.
I claim.
Yeah, I claim, number one, an inclinator comprising of a box-like carboy holder. So carboy is a glass, 5-gallon glass bottle or the like. So, space from the body of the carboy to provide a handle for manipulating the inclinator, a hook on said bar for engaging the body of the carboy, a link pivoting back. This is so you can safely upturn your glass, 5-gallon glass container with all of your fluid in it without dropping it. If I say you can lift it into this box. So imagine normally this box is upright. This portion here is sitting down near the surface, and you just lift your carboy into this box, cover it with this other box, clamp it in place with said awfully complicated clamping mechanism. What's up?
You look different on the
How so? Do I have very red lips? Because that seems to be a thing with these cameras. Look at this complicated locking thing. Yeesh. Nice little pin on a string here that's going to get lost. Adjustable rack, too, in case your carboy is bigger or smaller. This top portion just slides into the bottom portion, I guess.
Totally.
Should reasonably useful. And for 1914, it probably is, well, it's not the first, but it's probably one of the very early ones. I bet everybody got tired of putting all the parts together, and they were like, whatever, I can lift it. I lost a few of them along the way. Alrighty, moving on. Let's try this one as a design patent. Shall we? I don't think there's that many design patents.
Don't be a penis.
It's a badge. M.M. Ewin did file a badge in 1952.
Ooh, what is it?
I'm not sure. It looks like a firefighter kind of a badge. Ewan. Got an axe and I don't know.
Ewan McGregor.
Ewan. And it looks like he's got a nice little clampy mechanism to clamp onto the back of your shirt. You know, a little nub here to rub on your chest while you're moving around. Totally convenient, right? Well, that's the extent. No, it's not. Got to go to the full pages. All right. Yep, that's the extent of the patent. Ornamental design being substantially as shown and described. Another Minneapolis, ornamental design of a badge for which the following is specification. Doesn't really say the purpose of it. Oh, here's a reference. Myers Military Shop, solid gold emblems. So this is where he sold it. So showed proof of it being out in the world and not just a random design. Oof. Not particularly detailed pictures, but
solid gold. Jesus.
Well, I suppose we could do a Google image search on this and maybe there's an existing badge, but we'll leave that to others. Moving on, let's try that as a utility patent, since we didn't quite get all of our patent digits.
You didn't get your digits.
Too many digits. And we have here a method of laking paper. Laking?
Making?
Making paper. Making paper. I thought laking was maybe a technical term. I don't know.
That's what it says. Laking. Oh, man.
Making paper. Nice little container of goo. Here's your paper pulp coming out that way. Paper pulp come out. Gets all smooshed between rollers. Probably dried with some hot air from this thing. Probably. Little scraper bar to get you the right thickness. That's my theory of operation. Let's see. Method of making paper.
All right.
Big roller drum. Rupert P. Daniels of Adams, Massachusetts, assigned to L.L. Brown Paper Company, also of Adams, Massachusetts. Making paper of certain definite portions of a thickness different from that of other definite portions thereof. Okay. So varying portions of thickness of paper. Other objects and advantages of this invention will appear in here
That
and
is
after.
not very clear.
Well, making certain thicknesses that are different than other thicknesses. All right, so accompanying drawings for the purpose of this description to be illustrated applies ordinary Ford render paper making machine. Ford render. Ford render? Again, technical term.
Ford.
Ford driner? Drinier?
All right.
It's killing me.
In water.
It's killing me.
Making paper. It's this thing. Whatever.
Ford Drinier. So says Merriam-Webster. So let's see. Stock comprising fibrous materials and water is flowed in a liquid state onto a moving wire through which the water is permitted to percolate gradually, leaving the fibrous mass, forming the web.
How most papers made?
Pretty much, but I suppose my guess is that it's a continuous conveyor belt versus the individual wire frame of paper making, which maybe the first time there was a continuous feed process for paper making. I don't know, but let's see what he claims. I claim as my invention method of controlling the flow of fibers to form a paper sheet having designated areas of less thickness than the ordinary thickness of said sheet. So he can actually control the thickness of the sheet as it goes through the, I suppose, again.
Thank you, Email Force, the shout out.
So you're very welcome. Controlling the flow of fibers, various thicknesses. I don't know if you'd make changes to the thickness as you went, or just as you check it down the line and all that kind of thing. I don't know if you'd do it to create different thicknesses on one roll, but at least to control it. Guaranteeing thickness to a greater extent than the areas of normal thickness by applying fluid pressure and maintaining the difference in thickness until the fibers are set by continued application of fluid pressure. Let's see. So it's all really about the flow of the fibers onto the conveyor belt, which I guess is what was new and unique about this method of making paper. Yeah, it's all about the flow of the pulp. Restricting the flow of fibers to the area of less thickness to a greater extent than the areas of normal thickness, and applying air pressures thereto.
Air pressure.
Ah, well, there you go. So back up here real quick to the design. I suppose there's your air pressure. Looks like some vents. So paper pulp comes out. You're able to maintain the appropriate thickness using this mechanism here. And then vary that thickness so that when you check the thickness of the paper on the other end, you're probably within spec. I'm guessing that's the idea. And then this is sort of a view from above of the whole mechanism. So this is the top view. This is the side view. This metal container, heat box, or what have you, creates the air that comes down here and is flowed out here. This little detail, I believe, is this. This is the pipe. And these are the holes in it for the air pressure to come out. And, you know, it's kind of tricky. You got to apply just the right amount of air, and it's got to be evenly applied across the entire surface. And basically, it's just blowing the liquid pulp backwards along the conveyor belt as it goes. Interesting. 1926. Newspapers were exploding. No doubt there is more and more need for continuous form paper. Yeah. Which I believe the reference, so he's only referring to this sort of feed process right here. He's not referring to this whole continuous rolling method.
Size?
How's that?
Does it have a size?
Not really. I mean, you want your patent, if your patent can handle things from 2 feet wide to 6 feet wide, you want to not even really specify it. Having a certain width or a designated width is generally the way they'll go with it. But I believe this whole process of dumping pulp and putting it through a conveyor belt is still part of the standard way of making paper. He's just trying to say this is how you manage to maintain the pressure evenly with my mechanism. So he only claimed this air I feel like I'm repeating myself now. Anyway, you get the idea. Yeah. It's not the whole design. It's not the whole drawing. It's only what is in the claims. All right, moving on. View cart search. Oh, spirally looking pipe. Tube construction. This is how we make a tube. I'm assuming it's a toilet paper or cardboard tube for just about anything for all your cardboard tube names. 1919. I think I've seen this on How It's Made, where you have the strip of material go on to the mandrel, and it's sort of overlapped like that. I think everybody's seen a toilet paper tube somewhere in their life. Probably at the most inconvenient times. All you have left. So, tube construction. Mr. John F. Muldoon of Melrose, Massachusetts. Be it known that Mr. John F. Muldoon of Melrose.
She said you can make. And she took it back, retracted it.
Oh, darn.
She said you can make paper from dryer lint.
Oh, yeah. I don't know if you'd have enough to make a whole lot, but yeah, the traditional process of just having a very thick, pulpy mixture of either dryer lint, which is mostly cotton fibers, depending on what you put in a dryer, I guess. And then, or paper that's been shredded, or flax. Flax, you can do that. What's that?
Ours is dog hair.
I know. I don't know if you can make dog hair paper, but if you could, maybe we can patent it. So let's see.
You can make paper out of dryer lint.
The usual inner tube is made entirely out of rubber. and is itself has but little strength, the outer casing of the tube being dispensed upon for its support, dependent upon. As the outer casing becomes worn, it becomes weaker. Unless tear is taken, the tube eventually blows through the casing. Oh no. How dreadful. So it says tube construction. It doesn't say paper tube. It just looks like a paper tube. I just assumed it was a paper tube, I guess. A layer of fabric in the form of a strip, diagonally cut, is applied over said sheath and is featured of the invention that said strip is spirally wound upon, spaced apart by the substantial distance as illustrated. So this is a rubber tube covered in canvas duck, any suitable fabric as canvas duck fabric. I've never heard of that. As may be employed, is cut on the bias or so formed as to admit the flexing of the tube without kinking. Don't need no kinky tubes. And a second sheet of tube 12 is uncured rubber and applied. So it's a combination of fabric and rubber tubing. I think we've seen that as kind of like a what do you call a firefighter hose, perhaps. So a little bit more substantial than toilet paper tube. Firefighter hose. So here's his claims. Spaced apart convolutions, outerly wound fabric layer having spaced apart convolutions disposed over the spaces between and overlapping the convolutions and so on. So pretty much just pretty much what it looks like. It is layers of fabric and uncured rubber to make for a tough tube. All right, moving on.
Yeah.
Yeah. Tube, not so interesting.
Tube. All right.
Let's see what we got there. Ooh, that is complicated. A bearing and direction indicator with a section map for vehicles, 1926. So believe it or not, I believe this was the early form of GPS for your vehicle, of all things. So you've got indicator dial here, which is clearly on this face, various dial mechanism to operate off of your wheel. You got some lighting to illuminate it from the back. Nice little compass going there. Let's see. So this is what it would look like if you're looking from above. I'm thinking this is the connection to your speedometer input. So let's see. Indicator for bearing and direction, which makes it possible for the driver to know from what section to section whether he is driven in the right direction, and which induces the driver, when he observes the indicator, to steer the vehicle at branch roads to the correct direction. So you come up to a fork in the road. This thing has realized that you've reached that fork in the road, and then the dial here would tell you whether you should take the left or the right road. And I believe I saw this on one of the car invention channels or shows. Basically, it's just tied to your wheel, and it, as you turn, the differential between the spinning of your wheels tells it how much you're turning, and so it kind of tracks what direction you're pointing. Assuming you set it all up to begin with correctly. Here we go. Road crossings. This ROM card comprising a hand which indicates position which the compass needle must adopt at the point in question. At the current direction of travel of the speed of the vehicle, the ROM card of the compass being further projected upon the section map. which registers each time with the RUM card marked in the section mapping question. So basically, as you drove, these dials turned, and not just in your current to show your current heading like north, south, east, west, but basically what direction your destination is, if you will. And then it would also have indications on the paper dial as to what location you were at. And then they sold the paper dials with different start and end points for different cities. Let's see what all he's actually claiming here. I claim a direction indicator for vehicles, a casing, a window in the casing, a transparent strip map in the casing, means operated by moving part of the vehicle for moving the map in front of the window, plurality of ROM cards in the strip map, each located a distance from the adjacent one, proportionate to the distances between the road branches. So as you travel, the map moves from, it's like a, I guess it's best described as an early triptychs. I don't know if you remember the triptychs maps. They were like maybe this long, and they were basically just along the route of all the major freeways and highways. And this is an early version of that. Now that's a fun thing to come across, but ooh, that's a complicated machine to try and duplicate. Plus, there's a lot of detail about how much information is on this strip map. So, looks like your strip map goes from one reel all the way across the glass, comes back here. You got your projection on there.
When was the first patent issued?
The very first patent was issued in 1893. It's for, as you would expect, a train thing. In fact, it's the train wheels that were patented of all things. We can find out by putting in number 1. Quick look at number 1. First patent, I did this one. There we go. The patent is for traction wheels for said train. You know how the wheels, if you noticed, looked closely at a train, you know how the wheels are slanted thusly?
Yeah.
And the reason is the wheels are on a solid axle between each other. So both wheels turn at the same speed. But when you go around a turn, the outer wheel has to turn faster or go further than the inner wheel. And since these are connected by a single axle, they can't actually change and run at different speeds. So the differential in your car is what allows you to do it in a car as you go around varying tightness turns. Well, in trains, all of the turns are the same tightness or within a certain tolerance. And so when this wheel, if it's the inside wheel of the turn, the momentum of the train car pushes to the outside of the curve. That means that this part of the wheel is on the track and it's running on a smaller diameter and is turning at a different speed than if this were the outside wheel of the train car. The track would be running on this part of the wheel, and this slope is enough to allow both of the wheels to turn at the same speed, or turn in unison, I should say, and effectively not squeal as it goes around the corners on the track. So it's all in the design of this slight slant in the wheel that allows the wheels to be ganged together and not require a differential mechanism between every set of train wheels. Or I suppose you could individually just have the wheels turn and just not have them connected to each other, but that would be kind of like front struts or something like that, which couldn't carry the weight. And that was 1836, first U.S. patent.
Wow. I can't believe that, 1836.
Yeah. 76, so 60 years. Sounds about the best, right speed. How long does it take you to set up a patent office? Actually, we cut them a little slack. It was 1783 was the Constitution. So, where they said they should set up a patent office. All right. Well, that was a good question.
Yeah.
Thank you
That was
for
from Dana.
Dana. Oh, okay. I did not see that here. I'm not sure why I'm not quite seeing.
Oh no, you're not, because she asked me that personally.
Ah, okay. Ooh, look, it's an iron. Pilot signal for electric heating devices. A pilot signal. Just to tell you that it's on or to tell you that it's off? Or to keep it on?
Ooh. In 1920?
Yeah, it's not the iron itself. It's just the pilot signal for electric heating devices. So let's go look at the full pages. Ray P. Farrell and Claudie Moon. Claudie. Citizens residing in Oxnard. In the Schnard. Oxblood.
That's what we call it.
Relates to an improved pilot signal for electric heating devices and has one of its principal objectives to provide an arrangement whereby the fire hazard incitement to the use of such fire hazard incident to the use of such devices will be materially reduced. So let's see. Further object to provide an arrangement wherein the pilot signal will be energized as long as the circuit of the heating device is closed, so that the operator of the device cannot at such times likely forget and leave the circuit closed to allow overheating of the device and a resultant fire. So I guess they didn't have much in the way of thermostats on these devices. So here's the side elevation of an electric iron embodying the improved signal. Guard and a signal lamp. Ooh, so, oh my God. This might be the earliest blinky light on a thing. How do you know the iron is on? The light's on. Turn on
blinky lights.
Unplug the iron before it overheats. In carrying the invention into effect, we employ a transformer capable of charging the voltage from 110, which is in your outlet, to 4 or 6 volts. Pilot lamp. Basically a light to tell you your iron's on. Let's see. Get down to the claims. Claim the first. Combination circuit posts with the heating element of the iron, handle bracket arms carried by the iron, transformer having secondary and primary windings, because that's what a transformer is. A combination of a primary and secondary wiring.
So an iron.
Well, it's
light on an iron.
It's the light for the iron, yes.
Okay.
That's pretty much what he's claiming.
Okay.
Apparently that was a problem. Well, how do I know whether things are turned on or off? I'll go look for the blinky light, or in this case, not really blinky, just solid on. Let's try this one again, but as a design pattern. Let's see what we get. Well, almost the same number as a design patent. Oh, it's a clamp. It's a portable vise. Very, very C-clamp looking shape. I guess it is portable because it's not mounted to anything. Let's see what we got here. George T. Cumming, a citizen of the U.S. residing in Kansas City. Ornamental design for a portable vise. Okay. Oh, I see. These here are these little tangs. So it's portable, but you would still sort of mount it, I guess. Looks like these are mounting brackets. So much for portable. All right, well, moving on. Let's see what we have. Oh. A trouble finder for internal combustion engines. Looks like the handle of a gun. Some sort of cocking mechanism and a trigger. Trouble finder. Here we got the distributor. And the cylinders, spark plugs. I guess there's the points. Don't really have this much in cars anymore. Interesting. So this here's a trouble finder for cars. Looks like a little gun. I'm assuming this is going to let you see what cylinder is supposed to fire. Looks like he's got some diagram here, what cylinder's firing. I don't know. Let's give it a look. Guillermo Perez Castro, subject of the Kingdom of Spain, residing in New York City. A trouble finder for internal combustion. Let's see. Present invention consists of apparatus adapted to locate functional defects in any one or all of the cylinders of a multi-cylinder internal combustion engine, and more particularly that of an automobile or airplane engine. It operates to short-circuit the spark plugs of all of the cylinders with the exception of the one under observation, so that the action of the cylinder which is functioning may be observed and that its defects noted. All right. Might be useful. Seems to be limited to a 8-cylinder engine, but let's see, where is his claim? A series of contacts adapted to be electrically connected to the spark plugs of the multi-cylinder engine, plate adapted to grounded to shaft carrying said plate means we're rotating and reciprocating the shaft to move the plate into and out of engagement with the specific contacts. So basically you push the button to go from contact to contact and to cause this to spin, and you pull the trigger to do the test. All right, helps you find which cylinders are not firing. So again, in talking about claims versus what they're actually drawing, nothing in the claims actually claimed, well, so far. Let's see, spring inwise movements, spark plugs, multi-cylinder, contacts include shaft, lever, plate, and contacts. So yeah, it doesn't look like he's specifically claiming that it looks like a gun butt or the shape of a gun. So this shape here is not part of the claim, although he might also have a design patent for it. Anyway, moving on. Let me know how long you can you're going here, and if you lose interest, we'll go ahead.
I lost interest with that.
You lost interest with that. But you never know what you'll find. This next one might be super weird. Not so much. It's an internal combustion engine. Okay, well, it's in another internal combustion engine of some sort. Let's see real quick if he has any
a light bulb.
Fancy claims.
By Lou Crenshaw.
Base, a cylinder, and a piston provided with a sleeve. Yes. Okay, that's pretty much a standard piston engine.
Internal combustion engine.
Base, yeah. So he's got a few claims. 6 specific things.
She says she is surprised that patents started that long ago.
Yeah, they were declared that the patent office should be set up, and there should be a time that people's intellectual property is protected, so that they'll invest in creating new things. But that also, when the patent runs out, that whatever is new and unique about this thing be available to the public for the ability to build on that invention, instead of everybody reinventing the same internal combustion engine features over and over again. but it is in the story of Harley Davidson. There was a debate about who designed a particular carburetor, I think it was, and the people that originally designed the carburetor went after Harley Davidson for them infringing on the patent. And so, of course, what does Harley Davidson do? They look at all these claims. They go, oh, let's see, it's an inverted cup-shaped head having a circumferential wall fitting and interior surface. Okay, instead of an inverted cup shape, let's make it an inverted egg shape. How about that? That doesn't directly violate this claim. And they would go back and forth refiling inventions and refiling claims against other people's inventions based off of minor changes like that. Say, no, my internal combustion engine is better because this inverted shape is different, or the piston is different, or something along those lines. But that's done all day, every day. There are companies looking at old inventions,
or better,
looking for how they can build on the improvements or get around some claims so that they can otherwise build the rest of their item. Let's see here. Pencil sharpener. Ooh, scintillating. Well, I believe we know how this works. Here's said big unchecked sharp blade.
Should go to some newer ones, maybe.
You want to try some newer ones?
Perhaps.
Let's try some newer ones. If we get much newer, we can actually search by subject. So how about we, oops. Let's do a quick search. And I believe you said music was one suggestion along the way.
Yeah.
Let's see what kind of music patents. These are from 1975 and forward. So let's see. We got a thumb piano. A thumb piano, oh, it's a design patent. Let's see. There's your design patent for a thumb piano. Blink, 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 blink.
Oh. You made a thumb piano.
Right? Music has a system and method of Wi-Fi offload in What? That's a music patent? Tool tracking system, audio spatialization. These are all 11 million. They're really current. So let's see what's sort of the oldest. These are all designs. Really?
Yeah, those are too current.
A little too current, huh? All right. Well, then we'll just change our random list. Well, first off, let's copy this list so that I don't have to go searching for them and typing them in individually later like I did last time. All right.
Yeah.
All right. Random.org. Let's just do 10 more, maybe. Let's start at, say, number from 1 to 10.
Sure.
What? Any number from 1 to 10? 4. So patent number 4 million.
7. 7.
4 million to 7 million. Get numbers. We'll go back. Make it one column. There we go. These should be some more modern ones. Method for detecting proteases? Sensitive rapid capable of screening numerous samples in a small volume. Proteases?
What is that?
I believe it. Yeah, biological sampling. So, biological testing of some sort. I do not know. Now, there's the danger in getting too current, as we get all sorts of, sort of non-visual patents, if you will. Just not terribly interesting diagrams. Alrighty. Alright. Well, let's see. Let's try something in the 5 millions. All right, let's see. Let me try not butchering this, but here we go. The composition of polyepoxide derived from alkaloid substituted alkyphenol and carboxy-terminated polyester or polyamide.
For what?
This appears to be a chemical. Epoxy compositions having improved toughness and flexibility, comprising a polyepoxide of the formula, and this is the formula, which is some diagram I'm unfamiliar with. So if you're familiar with organic chemistry, this probably makes total sense. He has 16 claims and no drawings. Boring. Again, this is the danger of the current. Here, we'll just take the, let's knock it down by 1. Let's go from 5 million to 4 million on this one. See what that gets us. A suture cutter. That looks painful.
Ouch!
Alrighty. Let's see. Oh yeah. You just stick this little part on between your stitches and your skin, and then you clamp right down on it. Boy, isn't that useful? Ow. That looks painful. All right. Yeah. Nice little pair of tweezers looking thing. You'll like this one, I think. So this is a suture cutter, right? You get this jaw right here. You get up in between the sutures in your skin, right?
No.
Kind of like that.
Oh, yes. I know what that is.
Yeah, I've seen them probably before too, right?
Yeah.
And that was from 77.
So Dana says, do they list patents by state? And if so, what is the most valuable or important patent in Oklahoma?
They don't specifically list them by state. It'd be hard to say. I guess it's the state of the inventor or the state of the assigner. Why a suture cutter is being assigned to the International Paper Company of New York is kind of beyond me. But in any case, so yeah, it'd be a little bit difficult to track it down by state, and the most valuable patent from inventors in that state. Wouldn't be impossible. It'd just take a little research.
All
right. You can certainly do it more readily for the patents from 1975 forward.
Right. Where that's really...
Where they bothered to actually digitize all that. Now, Google Patents, I think, allows you to search older patents by assignee, assignor, all those various parameters. But they did it by just scanning the old documents and recognizing the text in them, which is not particularly accurate, especially for, I think they did all that around about 2002, 2003.
That's smart.
All right. So 5 million, so see if we get something
No suture cutters, come on. Man.
Pharmaceutical composition of activity in the treatment of cognitive or neuroimmune dysfunctions. A pharmaceutical composition with the beneficial effects in disorders which deal with cognitive. So this is a drug patent.
A lot of drugs.
It's a drug patent. What fun!
No.
And the exact administration of 100 to 1,200 milligrams per day. Let's see if he's got any useful diagrams. Nope, no drawings. Wah wah.
I don't like the ones with no drawings.
I know, right? That's why I thought we'd go with some of the design patents. Since they were,
I'm back. I'm okay with going back to the design patents. But
let's try design patent almost that number. Go straight to the images. Samsung Electronics. So here's a more modern patent. You can see it's a lot more 2008. So it's a lot more specific. This is a DVD recorder. Design patent for a DVD recorder. And it references all of these other design patents by clearly who's the assigner, Samsung Electronics. So of course it's Mr. Park, Mr. Lim, Mr. Kim, Mr. Hong, Mr. Kwan.
Yeah.
And that's your DVD player.
Yeah.
Oh, I think I had one of these.
Right?
Not surprisingly, it's not particularly high detailed. And then these are all the various places where it's been seen or shown as
or used. Yeah.
Or used in industry, advertised, that kind of thing. So let's see. Alrighty. Let's grab another one. Actually, let's just tell it to find some more random ones. Here we go. We'll go with 454. All right. I think we're coming up on our limit. That's about an hour. Let's see. A removable printing disc coupling for printing machine. So in the newer patent, you get all of this data that was entered by hand originally.
Yeah.
Then you also get the patent documents that this references. So while he has some new claims, previous patents that are very close or very similar in nature have to be listed as well so that you can actually go back and say, back in 1975, there was a low-cost one-piece plastic coupling having inherent spring-like qualities. So this kind of sounds like that little thing that you stuck in the middle of your record player to play the 45s.
A coupling.
Yeah. Let's see what the images come up with on this one. All right. Not particularly sure there. Yeah. Not music related. But in any case, that's how you can sort of track a patent back to previous references and things that are similar in nature. At least with the modern patents you can.
Interesting.
Let's see.
Pitney Bowes.
Oh, was that Pitney Bowes?
Yep. So
that's probably a reel-to-reel or something to that effect, right? Or not a reel-to-reel, a typewriter. It was probably the coupler for the typewriter tape. Ooh, apparatus for detecting and recovering of binary data from an input signal.
Okay.
The circuit is described as recovering binary data from an input signal which may be phase-coded and non-synchronous and such and such. Walter to Allied Corporation. All the previous references. So this is describing electric circuit, I think. Let's see. Yeah. So there's your electric circuit diagram.
Yeah.
You got your antenna, your radio receiver, your amplifier, Not sure what that is there, but you got your 10.7 megahertz or 30 megahertz IF amp, and then a 10 megahertz IF amp. So they're looking for signals somewhere in this range, from 30 megahertz to 10.7. And detect the phase, delay on, detect the edge, start a counter, rising edge detector, another counter, squelch circuit so that you don't reread it. So you get a clock signal out that goes up and down, and then you get output data that apparently is, these are AND gates. So as signal comes out of the delay line, it's actually fed back in, or synchronized with itself, if you will, or synchronized with the signal before it was delayed. And that tells you how long your pulse was. I'm not sure why it's specifically a radio receiver, but all right. I don't know if you guys can hear all that snorting. Come on. Come on. Come here, you. It is puppy time. Puppy wants to be noticed. What? What do you want from me?
She wants to see.
I want to watch. Ah, she's going invisible. She's phasing out of existence. Oh, I wish your breath would phase out of existence. You stank. All right, folks. Well, I think this is the signal for I've had enough. You must play with me now.
Yes.
And so that's it for this episode.
Thanks, everybody.
Thanks, everyone, for coming in. We'll talk to you next time. Have a good one.